Hi, I'm Siu On, a prompt engineer based in Singapore. In this sharing, I'm sharing a way to develop a web app for answering questions in English using a trusted source of information and a large language model, LLM. Let's get started. Here is what I'm going to share in this session. First, why question answering app. Second, high level requirements for the app. Third, assumptions about my viewers. Fourth, essential concepts used in this app. 5, processing steps for this app. 6, why use LangChain. 7, demo and setup of the app. 8, sequence diagram for the app. 9, further work. Why a question answering app is an example of a low risk business case as described in the article, Unleashing the Power of a Large Language Model, a comprehensive guide part 1. Why use trusted information? For most companies, their users probably have a low tolerance for inaccurate information, probably due to hallucinations by LLM. Another limitation for LLM is it does not have access to the latest information. The confidence in the response increases by asking the LLM to use specific source of information only. Here are high-level requirements of the question answering app. The user can select one PDF file on a local drive as a trusted source of information. Second, the LLM can only use information from the specified source of information. Third, the average response time for each response should not exceed 5 seconds. Assumptions about the viewers are you have some experience in software development, but no experience in LLM required. The most important thing to take advantage of this sharing is curiosity. 2 questions I have while developing this sharing are what is the interaction style of this app? Question and answer or chat? As of August 2023, most users would expect a chatbot with a memory of the past messages, so a chatbot interface is supported in this web app. The second question, what is the best LLM model for the first app? For most companies, using a hosted LLM is the easiest option. Self-hosting is not easy for companies without in-house GPU infrastructure. Some developers have the opinion that using open source LLM is cheaper. That may be true in the longer term. For the first app, I argue that allowing the potential users to kick the tire is much more important than optimization, i.e. minimizing costs. So for this sharing, we will use GPT-3.5 Turbo, a commercial model by OpenAI. So what is token? According to OpenAI, a token often refers to a piece of a text, such as a word or punctuation. For instance, in the sentence, I love ice cream, there are 5 tokens. First token I, second token love, third token ice, fourth token cream, and the last one is actually period. So according to OpenAI, the developer of GPT-3.5-Turbo, the max tokens is 4096 tokens. Below are some examples. If your prompt is 10 tokens, you should potentially receive a response of 4096 tokens. If your prompt is 4000 tokens, the response should be up to 96 tokens. By the way, a prompt is an input passed to LLM to guide generation of a response. A prompt may include the questions and context information. We pass information from the speech source as context. Since the max token for GPT 3.5 Turbo is 4906 tokens, so we must pass the relevant chunks as context for each prompt. How do we find the relevant chunks in the PDF file? Before sharing more information on finding the relevant chunks in the PDF file, we need to understand embedding. Embedding in the large language model LLM like GPT-3.5 refers to a representation of data, often text, in a continuous vector space. The primary goal of embeddings is to translate high-dimensional data into a lower-dimensional form in such a way that semantic meaning or relationships between the data are preserved in the new representation. In word/token embedding, the idea is that words with similar meanings or usage will have vectors that are close in the vector space. Imagine a very simplified embedding space with only 2 dimensions. The word king, queen, man, and women might be embedded as shown on the slide. How to derive the embedding of each chunk? In this sharing, we use the model or mini LM-L6-V2 from SentenceTransformers framework. SentenceTransformers is a Python framework for the state-of-art sentence, text, and image embeddings. In essence, SentenceTransformers provide an effective way to bridge the gap between powerful transformer models, which inherently work at token level, and tasks that require understanding or representing the semantics of entire sentence or paragraph. An example is semantic search. To help us to reduce the time for creating embeddings, we use this FASTA model or mini LM-L6V2 from SentenceTransformers. How to find relevant chunks as context for the prompt? In this sharing, we use a cosine similarity method. For instance, king and queen are closer in this space than king and woman based on the cosine angle of a pair of vectors. That means if a prompt is about king, based on the cosine similarity method, we use chunks having king and queen as context. Regarding training in LLM lifecycle, a developer of foundation model will feed lots of general information to the model. For adapting a model for a new task or domain, the developer may feed it specific information. For instance, to develop Bloomberg GPT, a finance-focused GPT, Bloomberg use public and private financial tokens. In this sharing, the user provides a PDF file as a form of in-context learning. Regarding the process steps of question answering app, we use a diagram from LangChain. First, we load document. In this sharing, we use PDF file. Then we split the PDF file to chunks or splits. For the embedding, we use model O-LM-L6v2, and we store of each chunk / embedding in Pinecone vector database. And when users submit a question, we use LangChain to retrieve the relevant chunks for question answering later. This method is called augmented retrieval. Finally, we pass the question or prompt plus the chunk as context to the model GPT 3.5-Turbo for questioning answering. Here is the processing flow for this question answering app. Why use LangChain? The main reason is it supports augmented retrieval in a conversation. The second main reason is leveraging community intelligence. Of course, using an extra library introduces more complexity than calling the APIs of the tools directly. Hopefully, this sharing will reduce complexity in developing your first LLM app. The setup of this app is very simple. Create APIs from OpenAI and Pinecone, then update the .env environmental file with your keys. Instruction to run the app is also in the README file. To demonstrate this app, we use a popular article. Attention is all you need. First, load the file. Attention is all you need. The file has been uploaded. Let's ask some questions. My first question is, what is attention? Here is the response from GPT 3.5 Turbo. Attention is a mechanism used in machine learning and natural language processing that allows models to focus on specific parts of input data when making predictions or generating input. From the response, you can see that it understands the context. In this question answering, we are referring to an LM and not the English word attention. Let's ask another question. Say more. Okay, here is the response from GPT-355 Turbo. Yes, attention is a mechanism used in deep learning models, particularly in natural language processing tasks such as machine translation and text generation. As you can see, it understands the context and it actually remember quotation, the last prompt. Let's try another question. Any more? Here is the response from GPT-2.5 Turbo. Yes, there are a few additional examples of how attention is used in deep learning models. Blah, blah, blah. Here is sequence diagram for the app. When I first launched the HTML front end in the browser, it actually submit a request to create a session ID. When I have choose a file, it will be uploaded to Pinecone vector database, spaced and stored as embedding. When I submit my question, the server will use LangChain library to do similarity search, cosine similarity search, and return the relevant chunk. With the relevant chunk or split and the prompt, it will submit it as prompt to OpenAI using a check completion API, and we get response, and then the browser will display the answer. You may ask, what is next? To learn about the LangChain, here, check out this video. For more about embedding, watch the second video. One of the areas we can improve in this app is index management. In this sharing, we have not discussed how to update an embedding or remove embeddings. Regarding speed optimization, what can we try? One missing piece is black box testing. Example, how do we know the answer generated is reasonable in the context of the prompt? Alright. Thank you for your attention. It's time to pause this sharing.